Hello, I'm here to talk about the novel missense variant in TTBK2, which causes haploinsufficiency and abnormal phosphorylation in SCA11. Spinal cerebellar ataxia type 11, also known as SCA11, is a rare autosomal dominant neurodegenerative disease characterized by cerebellar ataxia, nystagmus, and dysarthria. Until today, it had been reported in 5 families, all with heterozygous truncating variants in TTBK2. This gene encodes for a tau-tubulin kinase 2 protein, which is involved in cellulogenesis, microtubule dynamics, DDP43 phosphorylation, and also the regulation of some transporters and receptors. Still, the disease mechanism linking TTBK2 and SCA11 remains unclear. For this study, we aim to characterize the pathogenic effect of a novel missense variant in TTBK2, which was found in 2 Portuguese siblings with a previous diagnosis of cerebellar ataxia. For this purpose, we used CRISPR-Cas9 technology, where we first created a cell line with the flag tag at the end terminal of TTBK2 to enable future studies, and then inserted this variant using a template for homologous direct repair. First, we observed that the levels of TTBK2 protein was reduced in the mutant cell line, which suggested that somehow this protein is being degraded, and also observed that KIF2A and acetylated alpha-tubulin levels were decreased in this same mutant cell line, which indicates that somehow the cytoskeleton dynamics is impaired in this cell line. An important target of TTBK2 phosphorylation is the TDP43, and here we can see that with the overexpression of wild-type TTBK2, there is an increase of TDP43 phosphorylation. However, with the mutant one, there was no increase observed whatsoever, which is a sign of the loss of function effect caused by this variant. Knowing that this variant somehow impairs or reduces kinase activity of TTBK2, we did a phosphor enrichment analysis followed by mass spectrometry, and the gene set enrichment and the overexpression analysis showed that several pathways related to neurodegeneration were altered in the mutant cell line. Also, interestingly, we were able to find some phosphorylated residues, and here we highlight the proteins P62, SMAD2, and NET4L. Also, the data from this assay allow us to detect potential targets of TTBK2 as KIF18A, and also enable us to detect important players in SCA11 as can be SMAD2 and 4. Thank you all for listening.